In our chi-square goodness of fit, we had nominal data compared row to row. Now we're going to have a chi-square that will be called a test of independence or contingency table. What this particular chi-square does, still comparing proportions and percentages of observed to expected, but we're looking for a test of independence between the rows and the columns. Is there a relationship that affects the proportions? Those proportions are still based off of nominal or ordinal level data, and we're still looking for statistically significant. A random sample of 400 men and 400 women were asked whether or not they planned to vote in the next election. With the results below, perform a chi-square test for independence with alpha equals 0.05. The reason we're going to do this chi-square test for independence is because not only do we have nominal data in our rows, we also have it in our columns, forcing us to do a different type of hypothesis test, one that is not just chi-square goodness of fit, one column of data, but multiple columns. Another thing that differs is how we figure out what's called the expected value. According to the formula, sum of the row times sum of the column divided by sample size. Here's more specific to this problem. I'll need my rusty trusty calculator to help me out here. If I'm looking for the row for vote, then I'm going to take 230 and I'm going to add 255. So in that spot I'll put 485. For the no vote row, I'll take 170 and add 145 for a total of 315. Now I'm going to do the men column. 230, 170. 400 men voted. 255, 145. 400 women. Total, 800 people voted. Now, in order to get the expected values here, I'm going to have to take the sum of row 1 and the sum of column 1 to figure out the men who voted. So that would be 485 times 400 and divide that by 800. So we'll take 485 times 400 and divide that by the total in our sample of 800. So I should be expecting 242.5 men. Go ahead and leave that decimal. Now let's do women. So again, I'll take 485 for the row 1 vote times 400 for the number of women who vote and divide that by my absolute total of 800. And I still get 242.5. So now let's do men who do not vote. So I'll be taking 315 for the no vote row times 400 for the men and divide that by the sample size of 800, 157.5. Finally, we'll do women who do not vote. And the numbers are the same. No vote row is 315. Women, there were 400. Divide by 800. The numbers will not always come out like this. So our expected values for men who vote, I would expect 242.5. For women who vote, I would expect 242.5. For men who do not vote, 157.5. And for women who do not vote, I would expect 157.5. Now you might be saying to yourself, self? That's great. What am I going to do with this? We're going to do a hypothesis test. I think there's a relationship between gender and voting. I could also say it symbolically. The chi-square value is not going to be 0. The observed and expected are not going to be the same number. If I do that, then I have to do the opposite for the null, the assumed values, that there is no relationship between gender and voting. If there's no relationship, then those things would be equal. The chi-square value will be 0. In order to perform our test, we need an alpha value. This one was again set at 0.05. And our degrees of freedom will change just slightly also. Where we used to only have to take the number of rows minus 1, because we have multiple columns going on, we'll also have to do that with columns. So in this instance, we had 2 rows, take away 1, and we had 2 columns, take away 1. Parentheses, then the multiply. I have 1 degree of freedom. 1 degree of freedom, alpha equals 0.05, looks like 3.841. So when I draw this out, 1, 2, 3, 4, 3.8 would be about in here. My critical value of 3.841 cuts off about 5% of the curve. So now we're going to need to get our calculated value, which is why we did all of this. According to my formula for chi-square, I will need to take my observed minus the expected, square it, and divide by the expected for all 4 pieces. And there's what my calculation will look like. So taking my rusty trusty calculator once more, 230 minus 242.5 equals, square it, and then divide by the expected value. For the women, 255 minus 242.5, subtract, square, and divide by the expected value. Then we'll go to the no vote men. We'll go to the no vote for men, 170 minus 157.5, subtract it, square it, divide it by the expected value, and then finally no vote for women, 145 minus 157.5 equals, square it, and divide by the expected value. Chi means add in the formula, so I'll take my values, and I'll just keep on adding. 6433 plus 6433 plus 0.992063, 0.992063. My calculated value here, 3.2728 9.2. 3.2 would be over here, not in the rejection region. So I will fail to reject that null. I do not have enough information. There is not enough information to show that there is a relationship between gender and voting in the population. Wasn't that fun? In statcrunch, we go to Stat, Tables, Contingency. This is a summary, so we'll click with summary. Our actual data is in variable 2, and notice the little hint to shift if you want more than one, which we do because we also have information in variable 3. Shift and click. Our row labels came from variable 1, and click Compute. Our chi-square value, 3.2727, with a p-value of 0.0704. Let's try another one. A researcher wants to determine whether the number of minutes adults spend online per day is related to gender. Random sample of 315 adults was selected and the results are shown below. Is there enough evidence to conclude that the number of minutes spent online per day is related to gender? Here's another hint that we're going to have chi-square independence. Related, and we have quantitative data. Categorical. So, rather than doing this one by hand, we're going to set up our hypothesis test and then go find a website. We think there is a relationship, that the chi-square value would not be equaling 0. They, the null, which always has an equal sign, say there is no relationship, that the observed and the expected for the chi-square calculation will be the same, or 0. Alpha is 0.05. In statcrunch, Stat, Tables, Contingency, which means relating to, and this is already summarized for us by category. Tables, contingency with summary. Our data is in variables 2, 3, 4, and 5, so shift and click to get all of them. Row labels are in variable 1, and we're going to choose a chi-square test for independence, choosing to see if anything is contingent upon the gender. Our chi-square value, 18.146, with a p-value of 0.0004. My p-value, 0.0004. Is the p of 0.0004 less than alpha, which is 0.05? Yes, it is. We will reject that null and we'll say, ha ha ha, we are right. An interpretation: at the 5% significance level, there is enough information to show a statistically significant relationship in the population between gender and time spent online.